Just thought I'd do a video on projectile motion. We've got a particle here, and it's just moving across the screen. And we've got acceleration, which is just vertically down, so there's no horizontal acceleration. Now the key points are acceleration changes velocity, and as the acceleration is vertical, it's all down, that means that there is no horizontal component to the acceleration. So only the vertical component of the velocity is going to change. Okay, the horizontal velocity is just going to keep constant because there's no acceleration in that direction. So there's no reason for it to change. So projectile motion is basically just two SUVAT problems. You've got horizontal and vertical. So if you can do your one-dimensional stuff, then projectile motion is a doddle. So we'll go through an exam question, which was it was a nice question actually. And here it is. Right, I'll just give you just a few seconds to read the intro to the question. Have a look at the sketch, and this bit here as well. Read A. And I'm going to tell you some of the key points, what I pick out. And the first one is this bit. Now I know there was a couple of you who had a few problems with that. Basically 5 ms, that means 5 milliseconds. So that is 5,000th of a second. So it's 0.005 seconds. If you want it as standard form, is that. The second thing is the ball has a horizontal velocity of 0 at A. So when it's here, there is no horizontal velocity, and it reaches a constant horizontal velocity at D. So what that means is they're telling you that the horizontal velocity from D all the way to G, it just doesn't change. It's always the same. So it's a huge clue. Now the first thing they want us to work out is the horizontal velocity from D to G. So just this point here. And you know, or I hope you know, velocity is just displacement, which I'm going to call S, divided by the time, which is T. Now, we know S, because that's just 0.68. And we know the time. Now each one of those, so from D to E is 5 milliseconds. Okay, now we've got 1, 2, 3. So we've got 3 lots of those, so that is 15 milliseconds. So you can either put that in standard form, or if you don't want to do it as standard form, that's just going to be 0.015. And if you do that on your calculator, that's going to come out at approximately 45 meters per second. So that should be a nice easy 3 marks. Okay, now the second bit, or A2, they want us to calculate, let me just get my arrow, right, they want the horizontal acceleration of the ball between A and D. So they want the acceleration from here to there. Okay, now you need your definition of acceleration, and that is, right, acceleration equals change in velocity. Now I'm going to do my change as my final velocity minus my initial velocity all over the time taken. Okay, so the top bit is just change in velocity, and this bit is time. So all we need, okay, this is all we need. We need the velocity at D, or the horizontal velocity, and we need horizontal velocity at A. Now they tell us what the horizontal velocity at A is, and it's 0. Okay, so that means that U, because that's the initial velocity, that's going to be 0, and we just need the velocity at D, the horizontal velocity, and we got that from AI. So that's just 45 meters per second. So that just becomes 45 divided by, now we've got to work out the time, so each one of these is 5 milliseconds. So it is, so that's 5, 10, 15, so it's 15 milliseconds again, which I'm going to write as 0.015. Okay, so it's just 45 meters per second divided by 15 milliseconds. And that comes out to, what does that come out to? 3,000 meters per second So that's huge acceleration. So every second the velocity increases by 3,000 meters per second. Let's go on to the next bit. This is, just get my arrow. Well, D, that's where the ball leaves the racket, and it tells you the height above the ground that the ball was, and we've got to show that the ball would fall to the ground in about 0.7 seconds. So this is just vertical suvat. So I'm going to take, because the ball's going down, I'm going to take everything down as positive. So we're just going to ignore everything horizontally. Okay, now it's just suvat. So S, V, T. Now I know S is 2.3. U is 0 because it's vertical. Okay, so even though the ball left the racket with a horizontal velocity, we're not concerned with that. We're just knowing vertical, and it didn't have any vertical velocity. V we don't know. A we're going to take as 9.81, and it's positive because everything down is positive. And the time we've got to show, and that's 0.7 seconds. I'll put my units in. That's meters per second. Meters. Now the suvats I'll put over here. I'll put this over here in case you can't remember. I'm loving this. This is explain everything. This is pretty cool. Okay. Put myself out for a job. There we go. Right, now we want basically we want T, and we've got S, U, and A. So it's going to be this last one. Okay, so if we put in the values, we've got 2.3 for S equals, now U is 0, so that's just going to disappear, that's going to vanish, and we're left with A over 2, so that's 9.81 all over 2. Now because it's a show that, okay, you don't actually have to solve this, you can just put in the value for T that they give you. Okay, and if, I'm getting flash now, I'm changing colours. Right, now if that side comes out the same as that side, you've shown it. Okay, so that's all you have to do. If you do that on a calculator, it does, so it's 3 marks. So that's all there is to that one. Now B2, this is horizontal distance. Okay, so you've got to work out the horizontal distance that the ball will travel after it leaves the racket. So the ball's going to do, if this is, let me get good, right, if this is the ground, there's the ground, and let's say this is where the ball leaves the racket, it is going to go something like that, and they basically want this distance, this horizontal distance. Okay, so because it's horizontal distance, we don't have to worry about anything to do with the vertical stuff. No gravity, no acceleration, nothing. And the other thing is, because it's horizontal, we know that the horizontal velocity is constant, it never changes. And we also know that it was 45 meters per second. So when it left the racket and the ball was here, okay, that was 45 meters per second. We got that from, I think that they gave you that information and we had to show it. So that velocity, that will never, even when the ball's there, change colours. Even when the ball's there, it's still going to be 45 meters per second. And we know the time that the ball is in the air because we got that from BI. Okay, we know that's 0.7 seconds. So we know that the time is 0.7 seconds, and we know that the velocity, I'm just going to put v, so it's not final velocity, it's just v. We know that's 45 meters per second. So if we wanted to get the horizontal distance, all we need to do is s, which is equal to v times t. So you're going to do 45 times 0.7, which is 31.5 meters. Okay, now the reason I just did v times t is because the velocity is constant. If the velocity is not constant, you can't use that. You have to use the Suvat equation. You can use a Suvat equation even if v is constant. You can have u and v the same, and you'll still get the same answer. So, for example, if you would have used s equals u plus v over 2 times t, and if you were to put in u as 45 and v as 45, you'll still get the same answer, because 45 plus 45 is 90, half it you get 45 back, so you basically get this back. So it's up to you how you do it. Okay, but it was a nice question. Anyway, I hope that helps, and see you later.